In the periodic table, the numbers at the top of the columns tell us how many outer electrons the atoms in each column have. So in group 1, the elements all have one outer electron. In group 7, they all have 7 outer electrons. This helps us to understand what happens when two elements come together in the process that we call ionic bonding. We've already heard that the elements in group 1 with one outer electron, although they're electronically balanced, they also would like, in inverted commas, to actually have full outer shells of 8, which means shedding that one outer electron. We also saw that the elements in group 7 have 7 outer electrons. They would also like to have a full outer shell of 8, and therefore they need to gain one outer electron. Let's look at an example of that. On the right-hand side we have an atom of chlorine, and on the left we have an atom of sodium. The sodium, if you look on the periodic table, has 11 protons, and therefore it also has 11 electrons. The chlorine has 17 protons and 17 electrons. In other words, the negatives balance the positives. If the two come together, then the sodium will tend to shed its outer electron, and it becomes received by the chlorine. This creates electronically unbalanced atoms, even though they've got full outer shells, and so the sodium becomes a sodium ion because it's got now one less negative than positive, and likewise the chlorine becomes a chloride ion because it has now gained one electron, and it becomes Cl-. Because the two are oppositively charged, the sodium is positive and the chloride is negative, because opposites attract, the two will bond together. We see a similar situation with magnesium and oxygen. Now magnesium isn't in group 1, it's in group 2, so it has 2 outer electrons. The oxygen is in group 6 and has 6 outer electrons, and therefore it needs to gain 2 in order to get a full outer shell. The magnesium needs to lose 2 to drop back to its previous shell of 8. So the magnesium passes 2 electrons to the oxygen, and in the process becomes positively charged, whereas the oxygen receives 2 electrons from magnesium and becomes negatively charged. It's not always that straightforward. Let's look at another example. This time we'll look at magnesium in group 2, and we'll look at chlorine in group 7. Again, the magnesium has 2 outer electrons. The chlorine has 7 outer electrons. So the chlorine is hungry for one more electron, which it can receive from the magnesium atom. However, that then gives the chlorine a full outer shell, but the magnesium now has a lone outer electron still present. If we bring in a second chlorine atom, then what happens is that that lone outer electron is then passed to the second chlorine, and that causes a bond to form. The resulting substance is magnesium chloride, MgCl2. Observing this helps us to see how some of the formulae that we encounter are actually derived.